Hello everyone, this is the fourth video of the vulnerability research on the Linksys E1200 version 2 wireless router. In this video, I will be walking through the basic system enumeration steps to understand the binaries provided by the shell, which as you can see happens to be BusyBox in this case. So to quickly recap what we have covered in the previous video. First, we were able to identify the ground and UART components on the printed circuit board. Next, we were able to gain a shell from the UART interface. Okay, so going back to the technical write-up page, we can see here I listed out a bunch of system enumeration steps and commands. However, I will only be going through a few important steps in this video, and I will leave the rest for you to read on your own. Okay, so let me just put the screen side by side with the terminal for us to see more easily. Anyway, so first, boot logs. So the boot log will actually give us a lot of important and useful information for us to investigate the vulnerabilities. So for example, you can see here the version numbers for both the CFE. Okay, actually let's just take a look at what is CFE version router. So common firmware environment is a bootloader developed by Broadcom. Yes, this machine and this device is running Broadcom. Router acting as the BIOS to initialize hardware and load the operating system. Yeah, so basically it's just all the versions loading the firmware. Right, okay. Anyway, so we can see the version number, which will be useful for us to potentially find vulnerabilities, similar to the Linux version over here, which you can see if you to scroll down over here. So this version number can potentially allow us to find known vulnerabilities on these versions and to be exploited for us to gain access or somewhat like that. Okay, so over here you can also see the kernel command line information with the init script or init binary running sbin pre-init, as we can see over here. So this will be useful for us to investigate further in the future or when needed. So a particular interesting information we can gather from the boot log will be, as you can see if you scroll down further, a bunch of system commands that is being executed as the system boots. As you can see over here, cmd. So a particular interesting command which I found would be the cesmdns. So as you can see over here, given to the -h flag would be the value. This is machine name. So as you can tell, this value can be directly controlled by us. Therefore, given that we are able to insert symbols or characters such as you can see below over here, the semicolon or the pipe symbol, which in shell command indicates for us and allows us to split different sections of the instructions or commands. Therefore, given that we insert this inside this field over here, we might be able to insert custom malicious commands, giving us a remote code execution vulnerability via the command injection. So this can be quite dangerous, as we know over here that the system commands is being executed as the root user. So later on in the next few videos, probably at the end, I will be going through in depth about this command injection vulnerability and how we can gain a shell. Right, so right after viewing the boot logs, we can go on to look at some useful commands that can be executed on the system. So first, we can view the available memory using a few commands. So let's use the free command. Let's escape from here first. Clear and run free. So what is this? This command allows us to view the currently available memory space. So this is useful because embedded devices usually have really low memory space or limited memory space. Therefore, being able to keep track of the available memory will be very useful. Alright, so next, you can see you can also view all the available binaries. So first we can run echo path for us to view the directories which stores the binary. And as you can see here, ESR bin, bin, ESR sbin, and sbin. So we can just use these commands to list the binaries in each of the directories. Another useful command also would be the help command, which is provided by the busybox shell as we have here. So it shows us all the built-in commands. Or we can also, for example, take the first one and also view the available binaries. So a particularly useful binary under the user bin directory would be the wget tool over here, as you can see. So what is wget? So wget is a free command line utility for non-interactive network-based file downloads via the following listed protocols. So in our case, we will be focusing on the HTTP protocol to transfer files between the device and host and device. So in the next few videos, I'll be going through on how we can use this tool to transfer the files. So next, you can see the architecture and stack protections. So I'll be focusing on a particular command here, which allows us to view the current ASLR protection, which with value 1 indicates partial ASLR. So what is ASLR? This basically refers to the address space layout randomization, which is a computer security technique that prevents memory corruption exploits. For example, buffer overflow. So it randomizes the memory locations of key data areas such as the stack, heap, and libraries each time a program runs. However, later we will realize that due to the fact that the system only employs a partial ASLR, that means that it does not fully randomize all the memory addresses. Therefore, we could exploit that and still be able to execute remote commands via the buffer overflow vulnerability that we'll take a look at later on. So next, we can take a look at discovering the firmware version. So it's common to find the firmware version number via the web interface running on port 80. So as we have found and mentioned, as we have learned before, our firmware version is 2.0.02. So this provides us with a direct way to view the firmware version. We can also use the nvram command, which allows us to also view the version number, as you can see here, via the WPS model num parameter. So nvram basically just allows us to view the contents of the non-volatile random access memory. And lastly, for the HTTPD binary concerning the CVE that we wish to investigate later on. So given this command over here, find command, you see that there will be two outputs. And to describe a little bit about this command, find command, this indicates the root path from which we will start searching. The dash path basically specifies the search string, which includes the HTTPD search pattern along with the asterisk to match any directory patterns to allow us to match values such as this. And for the last portion of the command, this basically just tells find to flush and throw away all the error messages so that it does not mess with the output. And as for the output, you can see over here, this will be the important output as it provides us with the full directory or full path of the HTTPD binary. We can also run ps command and grab HTTPD for us to view the information of the process with the PID 325 running as the root user. Right, so a particularly important concept I'd like to touch on also would be the file system permissions, which we can view using the mount command. So as you can see over here, it will list out a few or all the available mount points. So you can see that most of the mount points are RW, which indicates read and writable. So as you can see in the technical write-up, for the first one, the root fs indicated by the slash, which is the root file system path, it is shown to be read writable. However, it actually maps to the dev root partition when the kernel is loaded. And as you can see over here, the dev root is actually read only. And because of that, this root fs inherits the permissions of the dev root directory, and hence it is read only too. While for the rest, for example devfs, sysfs, and the rest listed over here, as you can see, they are all read writable as shown by mount. However, there's a particular caveat, because for the sysfs and for the proc, it is mainly for the kernel to generate data on the fly. So files can be created directly, but existing ones created by the kernel can be modified. So this applies for both the sysfs and the proc. For example, existing files created by the kernel, such as the proc sysnet IPv4 IP forward, can be modified. So this is particularly for the port forwarding configurations. While for the devfs and the ramfs, it is fully read and writable. So a quick illustration for this, you can see over here, if you were to try echo test into a particular file under the rootfs directory, you will see that you get an error. Also, for example, as for proc and for sys, you'll see an error too. But for dev and for the tmp, there will be no errors, as we are able to write into these file systems, or these mount points at least. So we can then cat dev test, you can see it exists. For tmp2, it exists. However, for the proc, there will be no such file that exists, and also for the other, which is sys, or even directly in the rootfs, there will be no files that exist. So this knowledge is important for us later on in the exploit development phase, when we are interacting with the system via our payload. So with that, we have come to the end on this video topic on system enumeration. So in the next video, I'll be going through a few miscellaneous steps, such as how to reclaim memory space on a device, transfer files between device and host, and to also provide additional access to the shell via a dropbear SSH server. So I will see you there.